Solving trigonometric equations. Let's take a look at this situation. We want to find out, is pi over 4 a solution to sine of theta equals 1/2? Well, to determine that, we're going to plug this in. Since this represents an angle in radians, we plug it in for theta. And we can use our unit circle is the sine of pi over 4 equal to 1/2. Go to your unit circle, go to pi over 4. The definition of sine is y over r, or just the y value on the unit circle, and it is not 1/2. So pi over 4 is not a solution. The sine of pi over 4 is the square root of 2 over 2, which does not equal 1/2. Okay, let's try another one. Pi over 6. Is that a solution? Well, let's plug it in and find out. Sine of pi over 6, does that equal 1/2? Okay, so looking at our unit circle, finding pi over 6, sine, definition is y, 1/2. So yes. So the pi over 6 is a solution to the equation. Okay? And that's kind of how you can test, your angle to see if it is a solution. Let's move on to another example. By the way, notice it says a solution. Since sine is periodic, which means it repeats, there's an infinite number of solutions. So pi over 6 is just one solution of many. Okay, so that's example number 1. Okay, example number 2. We have the cosine of theta equals 1/2. Now what I want to do is I want to give a general formula for finding the solution. It's a general formula. And so once we find a solution to this, whatever that solution is, we're going to add 2k pi to that solution. So in other words, let's just go ahead and find a solution. So cosine of theta equals 1/2. So the definition of cosine is x. So as we're going through here, x value, we're looking for 1/2. So a solution to this is pi over 3. So pi over 3 is one solution. We're going to have pi over 3. Now to write a general formula, because remember there's an infinite number of solutions if the domain is not restricted. So we have to tack this on to count all of those solutions. Okay, so for example, if it is on the first time around the unit circle, k would be 0. K is any integer, so 0 times 2 times pi is 0, giving us a value of pi over 3. And okay, now is there another solution that works? We're looking for 1/2. So keep going around the circle. No, 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 no. Yes. So 5 pi, sorry. So here we have 1/2. Cosine of theta is 1/2, so 5 pi over 3. Now this is all within the first period of cosine. Cosine does not repeat itself until after 2 pi, and it repeats itself again. So there's pi over 3, and as you go around, there's 2 solutions, and 5 pi over 3. Both give you a value of 1/2. So 5 pi over 3 plus 2k pi. Now let's say that I want to get not just one solution, not just 2 solutions, but let's say I want to get 8 solutions. So it's pi over 3 when k is equal to 0. But what if we make k equal to 1? So if we make k equal to 1, let's see, k equals 1, okay? What is the solution? So it's going to be pi over 3 plus 2, we're going to make k 1 times pi. So basically we're saying, hey, we're going to take pi over 3 and we're going to add 2 pi. Why 2 pi? Because that's 1 complete time around. And when we end up back here again, what's the cosine? 1/2. So we're going to take pi over 3 plus 2 pi. Okay, we get 7 pi over 3. That's with 1 time around the circle. Now let's make k equal to 2. Now we have 2 times around the circle. So this is twice around the circle, that's 4 pi. So pi over 3 plus 4 pi is 13 pi over 3. Well, this is going counterclockwise. We also know that cosine goes clockwise. And so if we go clockwise around the circle 1 time, that would be a -1. So if we plug -1 in, now just so you can see, we've been going counterclockwise 1 time around the circle, 2 times around the circle. So each time we go around the circle, we've been adding 2 pi to this. Well, now if we want to go this way around the circle, remember going this way is a negative direction, so it's going to be -1 time around the circle, and we end up at -5 pi over 3. So right now we have 1, that's when k is equal to 0, 7 pi over 3, 13 pi over 3, and -5 pi over 3. And there's an infinite more. And we would do the same thing with the second one in order to get 3 more answers based on 5 pi over 3. Okay, example 3. A more traditional looking equation, basically solving for theta. And theta is going to be restricted from 0 radians, including 0 radians, to 2 pi, but not including 2 pi, because then we'd be back to, we'd have a little overlap here. So solving like a normal equation, we're going to subtract the square root of 3 on each side. Divide by 2. Okay, so now we're looking for where is the sine of theta equal to -3 pi over 2? Negative square root of 3 over 2, excuse me. Losing my... So we're definition of sine is y, negative square root of 3 over 2. Looks like right here. Sine y, negative square root of 3 over 2. So solution is 4 pi over 3. Any other solutions on this interval? And 5 pi over 3. Okay, and remember we're on this interval. So these are the only 2 solutions on that interval. Okay? All right, here's one for you to try. Please pause the video and give this one a try. Okay, and here are your 2 answers. I hope you got them right. Okay, on to the next example. Okay, let's take a look at this one. So the sine of twice an angle is equal to 1/2. So first thing we want to do is we want to just think of an angle. Don't worry about this 2 theta thing yet. But we want to think, well, what angle whose sine is 1/2? So just start off by writing that down. So looking at your unit circle, we have pi over 6. The sine of pi over 6 is 1/2. And if we go across, the sine of 5 pi over 6. So we're going to be working with those two radians. So again, we said pi over 6, and we said 5 pi over 6. And so what we do next is we're going to take 2 theta and set that equal to that, and equal to that. And to make sure that we get all the angles that qualify, we're going to write it using the general form. Even though we're restricted here, we're going to go ahead and write it using the general form, plus 2k pi. Otherwise, we might end up missing some of the solutions. Okay. Next thing we want to do is solve for theta. So we're going to multiply both sides by 1/2. So we get theta equals pi over 12 plus k times pi. This is the formula that we're going to use to get our solutions. Okay, same thing on this side. Multiply both sides by 1/2. So we're going to get theta equals 5 pi over 12 plus k pi. So now to get our solutions. Next, we're going to go ahead and use these numbers. -1 for k, 0 for k, 1 for k, and 2 for k. And let's see what answers we get when we plug them in. Okay, so plugging -1 in for k, we get a -11 pi over 12. Plug 0 in for k, we get pi over 12. Plug 1 in, plug 2 in, and so forth. Now, not all of these solutions they are, but not all of them answer this problem, because remember, our restriction is from 0 to 2 pi. So does this fall within that restriction? No. Does this fall within that restriction? Yes. Yes, that's just a little bit over pi, and that's a little bit over 2 pi, so that one would not fall. So these two would be solutions. Now you would use this same process with this general form as well. And why don't you go ahead and do this yourself and see what you come up as the other solutions that fit into this restriction. Okay? Now I want you to go ahead in your textbooks, I want you to go ahead and look over example number 5 and example number 6 in your textbooks. And your assignment, because I don't want this video to be too long, these are not too complex. One's a calculator activity, so I want to keep these videos as short as possible. Page 500 in your textbook, 8 through 40 even. This is due on Tuesday. Please make sure you started it so that you can ask questions on Monday. Although we will be finishing the test on Monday, so hopefully we can take about 10 minutes to answer questions on this on Monday before we finish the test. See you. Hope you're having a good weekend.